How do we orchestrate AI agents at scale? So this little graph over here is an example of our railway deployment, and it hosts a bunch of different AI agents that are responsible for different tasks. So if we just quickly look at the names a little bit, then we will see one is called like healthcare, e-commerce, dev code review, insurance claims, defense, manufacturing. And obviously like these are completely different industries, but you can imagine even within the same industry within healthcare, you can have multiple different bots, one for specific diseases, one for like triaging, one for like management and whatnot. And you have this entire ecosystem with all these different specialized agents. And they can do certain things, they can make intelligent decisions, and they have access to certain resources. And depending on which agent you're talking to, the level of access changes. Now, how do all these agents communicate with one another and interact and create extremely powerful workflows at scale? And that is where control plane comes in. So at Agent Field, we built a system called control plane, and it essentially acts as the centralized orchestration system. So you can imagine what we like to call it as the AI backend. So this effectively acts as the AI backend. You can imagine in IoT, you have a central hub that processes all the different IoT Internet of Things requests, or you can imagine the internet where people have their modem and routers and they get minted an IP address, and then they can connect to this centralized system which hosts all the different websites of the world. And you can query like google.com, and then it'll connect you to the Google node and show you exactly what website to render. So similarly, all these agents connect to control plane, and all these agents are able to interact with one another through control plane. Now, you might be wondering, why couldn't these agents just talk to each other directly? Now, a few things that control plane provides that they wouldn't otherwise have if they spoke to each other directly is control plane actually assigns each of these agents a DID. So what a DID is essentially is a credential that effectively acts as your identity. So each of these agents have their own unique identity. And with this, we unlock the power of authorization and authentication. So not only can we now let agents communicate with one another, we can also let agents communicate with one another knowing who they're talking to. And we can define these rules where, agent A cannot talk to agent B. And a better example would be, for example, let's just say you have an agent that is responsible for processing payments. And that is an extremely sensitive agent, right? You don't want that agent to go rogue, and you don't want other agents to access that agent and start processing these random payments that it shouldn't have access to. So then you can define that the agent that is responsible for processing payments can only be accessible by, let's just say, insurance claims. And every other agent that tries to query it will get rejected. And with DID and verifiable credentials, we can enforce this at scale live. And on top of that, we also have a audit trail. Verifiable credentials are cryptographically signed so that we can verify that the decisions that were made were actually made based on these criterias, which is extremely important and powerful when it comes to legal. If we ever get audited, or if we ever have to bring this up in legal, we can literally pull up cryptographically verifiable proof that something happened, and this is why this agent did X. And that is extremely important at scale, especially for enterprise organizations. Outside of that, control plane lets you organize all your different agents and let them communicate with one another with very basic APIs. So we have a couple of APIs that we expose in control plane, and one of them being discovery. So dev code review, for example, if it needs a specific skill or tool or whatever, it can essentially ask control plane and use the discovery API to see what other agents are available. And it can filter based on many criteria. And when it is able to find the specific agent that it could potentially use, like let's just say dev code review needs to research on a specific topic, and we have a deep research agent live. So dev code review discovered through control plane that deep research agent exists. So then dev code review can then call deep research agent with a specific query, and this discovery API will also expose the input and output schema So Dev Code Review Agent will understand what it needs to send and what it receives back. And in doing so, Dev Code Review can then call Deep Research Agent and get a response back, and all of it happens autonomously. And now you can imagine in a world where there are hundreds of agents that are live and that are specialized, and the dev teams are just continuously add more and more and more. And as you're adding more and more agents, you're actually making all the other agents more powerful. So if you think of an organization, as an organization grows, you have different departments getting stronger, more powerful, more specific, more niche. And people from other departments can have access to other people in other departments. And that is the power of a growing organization. And the same power is now applied to your AI ecosystem. So as you're adding more agents, as you're improving these agents, you're basically giving each individual agent more and more access to different tools and insights, making them better at their own tasks. And it's not just about building a stronger models now. It is about building better strategies to facilitate these agent-to-agent communication. And that will help you improve your workflow over time. Now, another thing that we also expose is memory. So agents themselves need memory. Agents across agents need memory. And then we need global memory. So we can obviously expose a database per agent. That is 100% possible. But as you can see, control plane is directly connected to a Postgres database already. And sometimes you don't need a full-on relational database. And sometimes you don't even need that much data. Like you might just be storing like a session ID or something. So control plane also exposes a memory API. And that memory API can be scoped based on how you decide that agent wants to scope it. So the agent can only use that memory for itself across the different workflow, or the agent could even use it at like a higher level and give other agents access to that memory, or the agent could literally make that global and give every agent access to that memory. So that essentially gives you the flexibility to use what you need. And if you really need a database for each individual agent, you need a relational database, you can always add one. At the end of the day, all these individual agents are essentially, like for Python, they're fast API servers. For TypeScript, they're Express servers. But regardless, you get the point. These are all actual servers, and you can hook them up to their own database. You can get them to use control plane's memory system. You can get them to discover one another directly or through control plane. It gives you that flexibility. And deeper than that, our SDK, so we provide 3 SDKs, Go, TypeScript, and Python. Regardless of which one you use, the power that our SDKs provide, which I'll quickly show you in code actually, is we allow you to define these 2 instances or these 2 values called reasoners and skills. So as you can see, this is orchestrator.reasoner, and then I believe at some point somewhere around here we will probably have a skill, or maybe in another file. But let me first explain to you what a reasoner is. So a reasoner is your intelligent module, your intelligent function. This is where you will basically provide a workflow that uses AI in some way to make intelligent decisions and to direct the workflow in specific directions. So you can kind of imagine, which I'll actually show you a graph. You can kind of imagine like this is your reasoner, and it spins out different workflows. And we're going to show you this live in action in a second as well. But let's go back to the code. In this reasoner, this review PR reasoner, so this is our pull request bot, for example, or this is our dev code review bot, for example. We first get the PR details, and then we actually use our note API, which I haven't explained to you guys what the note API is. The note API essentially lets you send server-side events directly to the front end. So your front end can subscribe to these events and get updates. Similar to how when you interact with ChatGPT or Claude, you can see like how the agents are thinking. Instead of like just getting, you put an input, you put a prompt, and you get an output, you actually see how it thinks through and how it makes decisions, and you get updates live. And in an AI first world, it is becoming extremely, extremely important that we provide good UX to our users, especially in this waiting state, especially when they're waiting 15 to 20 minutes at a time. So this note API lets us facilitate and send these events almost like push notifications, and the front end can subscribe to them, and then we can show them progress. which is extremely powerful in building good and useful UIs so that the person isn't left in the dark. They're able to see what's going on, and we're able to like show them stuff in a structured manner. Instead of just like a basic, update here, you can actually structure it out and you can do some pretty cool stuff here as well. But that's not the point. We also have notes. That's one of our features. But as you can see, at some point in time, we have a function called analyze PR, and the analyze PR is actually another reasoner, and this is where we construct our AI prompt. So as you can see, we expose a .ai function, which basically wraps your AI provider, and you can specify what provider you want to use here. You can actually do multi-provider setup, by the way, as well. You can specify, I want to use for PR reviews, I want to use Gemini 3.1 Flash Preview. Then for the actual orchestration, I want to use a stronger model like Claude 4.5 Sonnet. And then for the actual code writing, I want to use Claude 4.5 Haiku because the code itself is usually like it doesn't need as much intelligence. And you can basically create these multiple different providers and within different functions. You're not expected to use the same AI provider for everything. And we provide you the SDK to facilitate all that. And you pass in the system, you pass in the user, you pass in the data, and then you can also pass it a schema. So you could, in a Python, we use Pydantic, and you can say like, this is the exact schema that I want. And that basically converts it into a JSON and returns it back to us. And then we basically provide you it as a variable. And then you're able to then programmatically check the overall quality, risk score, total issues, and whatnot. And this allows you to, instead of think about the agent and think about the actual like plumbing per se, this allows you to, create your schema, send it off to the AI, get a response back, and write your workflow. So you are able to then focus on the actual business logic, and you let the AI infrastructure be handled by agent field and control plane and the SDKs. This will save you a lot of time. And not only that, it will also provide you with a lot of functionality out of the box. Memory, server-sided events, discovery. It will provide you authorization, authentication, all of that out of the box. And you're able to then create an ecosystem where you're constantly adding more and more and more agents. And at a big enterprise company where you have hundreds of thousands of departments and hundreds of engineers contributing, you can have a centralized control plane, and everybody hooks their agent into this control plane. And each time somebody pushes up an update, they are essentially making the ecosystem stronger and more powerful. And they are essentially creating workflows that can use one another and are protected from one another as well, which is extremely important. And you are able to create this very, very powerful and expanding system. Now, let's actually use one in action. So I have a little code review demo over here. So by the way, let me just quickly give you guys an overview of Control Plane's UI. So as we can see, similar to the Railway UI, we are able to see all the agents that are live. So if you were to do a discovery API pull here, you would be able to also see these programmatically. Now, if we look at workflow, this is actually where a workflow gets triggered. So if I start a review, we refresh this, we will see another workflow started. And as you can see, the orchestrator review spun up in analyzer PR review. So these are all individual reasoners, and this reasoner spun up another reasoner. And one more quick thing that I also want you guys to show you in a second, but before I do that, as you can see, orchestrator review PR is now in a waiting state. It is highlighted in orange, it's indicated as a waiting state. The reason is because orchestrator review is actually looking for human input right now. And that is one of our products that we will eventually release. But we call this our human in the loop system, which will basically take some input from the user. And this will pause the workflow. And we have pause, continue. We have all the different API functionality you'll need to orchestrate your agents. Sometimes your agents may need to pause and may need to get some input from a human. And you can receive that input through a webhook, which is exactly how this is implemented. And so let's quickly approve this. So let's just open this up. As you can see, this made a bunch of code request changes. theoretically, you're supposed to review this. I'm just going to approve it just so that we can watch it continue. And now we see that it unpaused and it went to the scan security. So you can essentially bring humans into the loop as well. As you can see now, it's looking for more human input. So if we quickly, did I close that UI? Yeah, I did. Okay, let me open it back up. Our UI should be around here. But anyways, that's not the point. You guys get the point. As you can see, like it pauses, resumes, it asks for input, continues, and then the workflow can infinitely expand. The workflow can also end early. It depends on how you program it. You can also do it recursively. You can kind of spin up multiple agents, hundreds and thousands, and sometimes our execution and workflows get pretty big. Like this is a smaller one, but we've had workflows that span to hundreds, 200s, depending on the complexity of the workflow. And the second thing that I quickly want to show you guys as well is we have something called skills. So if I can quickly find you guys a skill. Oh, this is a schema. 1 second. Security orchestrator merge. That's a reasoner. Security. Okay. So skills are deterministic, basically functions that will do some action. So reasoners have AI, so they're non-deterministic. That's debatable, by the way. Like with weights, you can kind of say it's deterministic, but like let's just hypothetically assume AI is non-deterministic, right? So reasoners are non-deterministic, and reasoners are essentially like the intelligent part of your system. But not everything needs to be intelligent, and sometimes you just need some of the functions to be functions, and that's where skills come in, and they essentially are very basic. Like for example, this is a utility that just returns security policy. You can argue that's not even needed. This one gets CI security results. These are formatters. This one scans through. And this one's a reasoner. As you can see, it scans through and then it makes AI calls. So this one's classified as a reasoner. And this lets you organize your code. And this lets you organize your system so things do exactly what they're expected to do and not more than that. And that gives you the power of cohesion. It gives you a very, very stable system. Because at the end of the day, you need skills. You need deterministic outputs. So you have your intelligent decisions, but at the end of the day, processing a payment is not an intelligent decision. The actual processing of the payment will be charge Abir $50, send it off to Stripe or some other payment integration provider, send it off to Zoom Rails, and Abir will then receive a payment for $50. That's a skill. Now, determining the price, determining the invoice, determining the other parts of it could be intelligent, and or determining the risk. A lot of financial systems, risk management is a massive thing, chargebacks, fraud, and whatnot. That is the intelligent part, and that's where your reasoners come in. So you're able to set up reasoners, you're able to set up skills, and your reasoners will be the ones that are orchestrating the different workflows. So your reasoners can essentially call other reasoners, and that's how you get that directed access graph or directed acyclic graph, and it spins up more nodes as you need to. Your skills are more they're leaf nodes. They just return the response or output in a certain format, pass it back to the reasoner, and the reasoner can end the workflow there, or the reasoner can spin up more workflows. And that is essentially how we think that is how AI orchestration happens at scale. And we have a lot of functionality out of the box. We actually also have a app.harness API now, which is available also in the docs, by the way. Everything is available in the docs. But app.harness, let me quickly show you guys. This wraps Claude Code and Open Code. So not only are you now able to make AI calls, you can also make coding decisions. You can make scripts. You can run the scripts and get some sort of output back. So the power that this gives you is, imagine one of your reasoner is responsible for creating graphs, right? Like it's a finance agent that's responsible for creating graphs. And creating graphs is pretty difficult, but you can ask, ChatGPT, Codex, you can ask Claude Code to create a graph for you. And then you from the Claude Code output, you just extract the final graph and you display in the UI. So now you're able to also harness the power, pun intended, you're able to harness the power of coding agents as well. And their super abstracted script writing, their coding execution, all of that stuff that they surface, you can also surface directly into your AI ecosystem, and you can give your micro agent, similar to microservice, the power of coding agents, which is insane. That is crazy. Let me also fix the layout because this kind of looks ugly. But back to what I was saying, we have built this entire system with users in mind, and all of this is open source. So the code is open to the public. We are welcome to your contributions. We are welcome to your suggestions. If you have questions, join the Discord. Feel free to message me privately or in the Discord help and support. I'm always there to help you. If you have suggestions or requests, we're there to help you. If you're creating, whether it's a chat bot, whether it's an AI ecosystem, whether it's a multifaceted workflow, we support all of it. We also open sourced a couple of different tools that you are open to use. We exported our coding agent as well, which, by the way, it abstracts Claude code, so it's not technically its own coding agent, but it is a facilitator. And the reason we recommend you use ours over Claude Code directly is because it spins up a project manager, it spins up a UX UI designer, it spins up a security analyst. It kind of does a lot of the manual prompting that you would do otherwise. We are also in the currently in opening up our PR review system. So similarly to the similar to the coding agent, the PR review system has a multi-step workflow and process to ensure that the code quality of a code review is good. And after it does its first or second iteration of review, you feel comfortable merging your code directly to main. And I think in an AI first universe, code reviews are gonna die, guys. Like, you can't release hundreds of thousands of lines of code and expect humans to review them. It's just far too much context, and even that needs to be automated. So we are going to release a lot more than that. We're going to release security. We're going to release man, I'm losing my words. We're going to release security, cloud security. We're going to release deep research agents. We've already released a deep research agent. We're going to release a lot of cool ideas and implementations of our system, which will give you ideas and inspirations into your own systems. And if you are interacting with any amount of AI and you want a production ready system, we have a bunch of Railway templates. So you can also find them directly on our GitHub repo. You can also ask in Discord. I'll link them to you if you truly can't find them. We're releasing more and more templates every week. So stay tuned for that. Hopefully you learned something. If you didn't, hopefully you're able to provide me some feedback and us some feedback, and we can improve our system and iterate on it. And hopefully you understand how AI backend works now. Thank you so much for watching, and see you. Bye.